Hi everybody, and welcome to our last class of the semester. I just want to thank you all for being my students. I've enjoyed having you. You've been a fun bunch. It would have been more fun if we were there in person. It's never as interactive or truly personal as when you're making videos and corresponding via the internet. But it's been a strange semester. I hope you all are well and stay well. Be safe, and best of luck in the future. For today, all I want to do is just review some of these conic sections ideas that we looked at in our previous class. So what I've done is I've made up about a dozen problems here, and let's just work through these together. For each part of this problem, I want you to classify the equation or the graph as either a parabola, a circle, an ellipse, or a hyperbola. So in part A, there's an equation, x squared equals 15y. In part B, x squared plus y squared minus 4x plus 4y equals negative 4. Go ahead and classify those two. Okay, you should have recognized that this is a parabola because there's no y squared term. And if you want, you could divide each side by 15 and rewrite this as y equals 1/15 times x squared. And now it looks a lot more like the familiar quadratic expression that you're used to. This one here has an x squared and a y squared, and their coefficients match up. Invisible 1, invisible 1. So this is a circle. Now you might say, oh, there's a negative number on this side, and aren't you supposed to have radius squared on one side, so that means you can't have a negative number since it's radius squared? But to make this into the standard form for a circle, you're going to have to do that process of completing the square to make these things work out. So you will end up having to add a number here, and of course then to the other side, and it will work out that you have a positive number on this side, or else it's not a valid equation of a circle. So bottom line, in this form you might see a negative number here, and that doesn't tell you right off that there's anything illegal about it. Okay, let me give you a couple more. Part C, 4x squared plus 25y squared equals 100. Part D, x squared over 9 minus y squared over 49 equals 1. Go ahead and think about those equations and classify them. There's an x squared, there's a y squared. It's not a parabola. They're being added together. Okay, so it's not a hyperbola. Is it a circle? Is it an ellipse? Coefficient 4, coefficient 25. Can't be a circle, it's an ellipse. Strictly speaking, You have to make sure that both these coefficients are either positive or negative if you're going to be adding them together. So it's an ellipse where a times c is greater than 0 in terms of our standard form for conic sections, standard form of the equations for conic sections. What do we have here? You see the parabola. You know, if somebody wanted to play, I'm sorry, you see the minus sign. I don't know where the word parabola came from. If somebody wanted to play a mean trick on you, they could put negative coefficients in here and start confusing you. But I don't think we need to do that to college algebra students. Maybe when you're all our advanced calculus students, we'll try stuff like that on you. But you see the coefficient of the x squared is, well, actually it's a positive 1/9, right? Because you're dividing by 9. Here, it's a positive 1/49. So you have a positive term minus a positive term with the x squared and the y squared. And these denominators are different, so, in fact, even if they were the same, it wouldn't matter. This is a hyperbola. If you're looking in terms of coefficients and the standard form, remember the general form, I should say, the general form of an equation of a conic section is this: an x squared term, an xy term, a y squared term, an x term, a y term, and a constant term, all cleared to one side, equaling 0 on the other side. So here we have a being a positive 1/9, and if you're thinking of this as addition, right, you're adding you're adding a negative 1/49 times y squared. That's why we say in this case a times c is negative. Again, we will try to trip you up on final exams with tricky stuff with this business. If you just see this general form, oh, coefficients are different, they're being added, hyperbola, ellipse, oh, the x squared term and the y squared term are involved in a subtraction, it's a hyperbola. We won't do tricky stuff with negative coefficients, because the math teachers at CCA are not mean. Okay, how about these two? In part E, quantity x minus 2 squared over 16 plus y, quantity y plus 1 squared over 4 equals 1. Just go ahead and classify that one. So you may say, wow, is that the ellipse thing? Or suppose I multiplied each side by 16. I could say, ooh, 16 is even a perfect square, nice whole numbers, just form a radius. But no, I mean, you're getting it to look like the general form of a circle a little bit, but you're never going to get away from the fact that you've got the 4 here and you've got the invisible 1 there, right? When you square this out, you're gonna, well, you don't even have to square it. You can just see like this, well, yeah, if you do square this out, you'll get x squared as your x squared term. Invisible 1 times x squared. Here you're going to get 16 y squared when you multiply this out. So you're going to see that a is different from c, which is equivalent to saying, oh, 16 and 4 are different, It's an ellipse. Okay, got the plus sign. It's an ellipse. It's even in standard form for an ellipse, which is set equal to 1. Okay, now I've got some graphs for you. What is that? Well, I hope that immediately you look at that and say, oh, 2 pieces, it's a hyperbola. Okay, that is a hyperbola. It looks like it's drawn with the center at 0, 0, though that doesn't have to be the case. You can arrange to have that hyperbola anywhere in your Cartesian coordinate system. How about this graph in part G? Let me fix my G here. Looks like a rugby ball kind of lying on its side, or a football that's not too pointy. You see that it goes through 3 and -3 on the x-axis. It goes through 2 and -2 on the y-axis. So it can't be a circle because there's no constant radius. Right here, the length is 2. Here, the length is 3. So this must be an ellipse. And then finally, what conic section is that? Well, I hope you looked at this one and you said, oh, that thing fails the vertical line test. That's not a function. That's fine. It can still be a conic section if it's not a function. In fact, all the others are not functions. Only a parabola that is vertically aligned opens upwards or opens downwards. That's the only thing that's going to be a function. This is a parabola that opens sideways. It's a horizontally aligned parabola. Okay. For your assignment, it's not really homework. You don't have to hand this in or anything. This is just for you to practice and review for the final exam. The final, again, is on Friday, May 8th at noontime, our regular class period time. You'll have 2 full hours to do it, between noon and 2 o'clock in the afternoon. It's an MML test, so I will make it available at noontime in MML. And don't forget to jot down all your work, and then send me pictures of that work so I can give you partial credit for anything you might get wrong. So, to get you ready for that final exam, I have 2 assignments for you in MML. One of them I named 8.7, 8.8 review problems. So there's just a couple of problems I worked through that. And then we have something from the math department, the final exam prep. So if you work all those problems, it covers everything that's liable to be on the final exam, all the topics anyway. Okay, well, good luck on the final and best of luck in the future, and maybe I'll talk to you soon.